Okay, hi everyone. Happy Saturday. It's day 4 of Advent of Code, and I've made a few changes to my setup here, so hopefully I won't run into the overheating issue at least. And I remembered to download my input ahead of time, so we're really off to a good start. Um, I don't really have much to do before we get into it. Yesterday's puzzles, even though I struggle a little bit, were relatively straightforward, I think. And I've started to add a little bit more comments to my code as well. So if you go take a look now, you should be able to follow along better. But anyway, let's get started with day 4. So for this puzzle, we're getting two lists basically. We're getting a list of numbers that are called out as we're playing bingo with a giant squid, and then we're also getting a list of boards, and these boards are 5 by 5, basically arrays, which as numbers get called, they get marked as called. They get marked as drawn, I guess. And so once you have a complete row or column in your board that gets called, you win. And then the score is the sum of all unmarked numbers times the number that was just called. So I think it may be, I may speed this part up again, but I think my plan here is to create a board class that can handle numbers being called on its own, so I don't have to worry about marking things as called. And then I think what I will do is I don't know if I want to store basically 2 copies of the board. I think so. First of all, the board will be a numpy array because list of lists would be annoying because getting a column would be slower and a little bit more frustrating. Syntax wise, I think a numpy array will be much easier to think about. And then the board class will have a method called draw number, which will just check, and if the number is in there, it'll mark it as called. And I haven't decided yet, like I was saying, how I'll mark it as called, but I'm sure it'll come to me. So anyway, I'm just going to go ahead and get started, and I'll walk you through it when I'm done. Okay, so I have written up the board class, and it actually works pretty well. I'm pretty happy with it. So the board, you initialize it with something that can be turned into a numpy array, which I think for us will be a list of lists. And the nice thing is it doesn't really matter what orientation it's in, so I don't have to care about which row goes to which column. It just needs to be in the same, it can be transposed, I think. And then it has a called board, which just tracks whether each position has been called. So basically, oh, you know what? I'm missing. Oh no, I did. Okay, great. So it just tracks which positions have been called. And then I wrote a quick thing to represent the board, which is just tell me which positions on the called board have been, or on the board have been called, just because that's what I care about. I don't really care about what numbers are there. And then I have each board has a draw number function, which it finds the index where that board has that number using this numpy where function, which returns a list of lists. So it returns, well, an array of arrays. It returns an array for each dimension. So for this board, we're going to get 2 arrays back. And if those arrays are empty, they have length 0, that means that the number does not appear in the board. So that's what we do here. Actually, I should return false here. So if I just check the first dimension because we're going to get an array for each dimension, and if the length is 0, then I return false because we didn't find it. And then if we did find it, I take the x and y coordinates, I mark the called board with a 1, and then I check if this board has 1, and I return that value, right? So the checkIf1 function iterates over first the rows, then the columns, and if it makes a one-dimensional array of those rows or columns, and then it applies this anonymous function which just checks if all the values in that are 1. That's what this, so all x equals 1, and then lambda x is just, you make a quick little function there. Axis just lets me iterate over rows and then columns, and then on my called board, right? The main board, obviously, they're never going to all be 1s. And then if any of these, so winning board is the array of true or false, right? So when it's iterating over rows, it's did each row have all 1s, and then when it's iterating over columns, did each column have all 1s? So it's going to be, even a winning board will have false, true, false, 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 or false, true, false, 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 right? So if any of the winning board, which is the array of true, false, was true, then we return true. Otherwise, actually, so I can just return, I just realized this. I don't need to check if that's true. I can just return, I don't know why I did it that way. Okay, return any winning board. Oh, no, I have to. No, because yeah, that's why I did it that way. So the reason I don't just return any winning board is that if we return, we won't keep checking, right? So we need to check rows and then columns because a column might have 1. And if we return any winning board, then we'll return a false even if the column has 1. That's why I did it this way. Anyway, then if none of that happens, I return false. And then score the board, I actually haven't tested yet, I just realized, but it returns the sum of the part of the board, that has not been called. Self.called board not equals 1 times the number that was just called. So let's just test that. So these are, let's print. So 0 plus, so 5 plus 10 plus 15 plus 20 is 20 plus 20 plus 10, 50. Great. So scoring the board works. So now that we've got this, I just need to write the function to read in our input. And if we look at the input, basically it's going to be the first few lines. This may actually all be one line. Let's see. Yeah, that's all one line, which is nice of them. So the first line is the numbers that we're going to call, separated by commas, and then the boards are separated by new lines, and the numbers themselves are separated by spaces. So this should be a fairly easy set of little things, little comprehensions. They're not going to be comprehensions. Anyway, you'll see what I do. Great. Back to fast mode. Okay, I tried a different idea. Of course, I was like, I know, I'll just use the strings themselves to make the boards. But it took me longer to figure that out than to figure out why my list of list solutions wasn't working. So now we've got all the boards get read in, which I printed out here. They're all 5 by 5, which is great. Let's check really quick and make sure that they look right. So the last board is 1786, 68, 23, 20, which looks right, and then 17, 41, 94, 30, 97. Looks great. So we have the last one, which is sometimes it's easy to lose the last one if you're not careful. So now getting the solution should be pretty quick. We should be able to convert this to let's just do a simple for loop. So okay, sorry, cat's here. So for number in numbers, where are my numbers stored? Oh, nums. That's not very creative. For board, God, I'll be right back. I need to throw my cat out. What we can do is for number in nums, we can call all the we can basically for each board call draw number, and what that'll do is return false unless that board wins. And if that board wins, we can just stop doing everything because we know that the board has won. So let's you know what? Yeah, that's fine. So let's make a function. Play bingo. Boards. Draws. And then for num and draws. For board and boards. Board.draw. Ugh, what is it? I named it something bad. Draw number. Num. If board draw num. So if this is true, that means that that board has won. So then we can just say return board.score board, and then num. Right? Yep. This should actually just work. So let's do print play bingo boards nums. Okay, there's our answer. Let's see. Great. So part 2. This is great. So this is a big advantage, I think, of working with classes, is that we don't really need to think very differently about anything. These boards can all handle all this stuff internally. So this is part 1. And then for part 2, all we care about is which board will win last. And to do that, we can go through the same loop as play bingo. We'll write a new function probably called lose bingo, let's say. Don't know how to spell. So for num and draws, for board and boards, if board.draw number num. So that means that when a board wins, we're going to do something. And what we want to do in this case is if there's more than one board, actually if there's more than 2 boards remaining, right? Because if there's exactly 2 boards and one wins, oh no, we play, because our input is going to be the final board's final score. So if there's more than 1 board remaining, we delete that board from our board list and keep playing. So boards, I believe it's, let's see, delete from list Python. Remove is what we want. Yep. Board, if len boards greater than 1, boards remove board. Else return board score board none. So let's try that. Oops, no, we want lose bingo. Boards nums. Ooh, too high. All right, let me do some some debugging. I'll come back after a bit. Two, 6, 3, 4. Great. Okay, so the bug I found was here in that code I was using. I was iterating over a list and then deleting elements from it as I was iterating over it. And if you do that, your index gets messed up. And I always forget that. I always iterate over a list and try to modify it. So instead, what I did is, if a board gets completed and there's more than one board left, I mark that board as completed. And then at the end of each number iteration, I delete all the boards that are completed with this list comprehension, where I only keep boards that have not been completed. And then that worked. So that's it. This is the first time I've had an excuse to use a class. I'm a huge fan of using classes because it kind of abstracts away a lot of stuff. I'm sure there's a way that you could parallelize this or do some clever stuff with arrays and arrays of arrays, but I think at a certain point it becomes easier to make a construct that can kind of handle all that stuff for you, so you can only think about one board at a time, and then once you've sort of built the architecture for that board, it scales really easily. So here we just wrote some of these methods that would handle all the stuff for the bingo stuff for us, and then we just had to make a list of those boards and write a function to iterate through that list. So that was it for this week. Thanks, and see you tomorrow.